Hello everyone, welcome back to my channel. I hope everyone is doing great. Let's solve 16th problem of dynamic programming study plan. Let me jump back to my iPad and show you the problem description and what was the approach. Okay, so the problem statement states given two strings word 1 word 2, return the minimum number of operations required to convert word 1 to word 2. Okay, you have the following three operations permitted on the word: insert a character, delete a character, and replace a character. Let's say you are processing a particular character from the initial word, then either you can insert a new character at this position, or you can delete this particular character, or you can replace a particular character with a different character altogether. Okay, but the final goal is to convert word 1 into word 2, and what will be the minimum number of operations required to convert word 1 to word 2. Okay, so let's just look at this example. Okay, if you see, in the first position I have h, and whereas the word 2 in the first position I have r, right? So I can simply replace h with r. Okay, now first position is matching with the first position in both the words. Second position is also matching with the 0 and 0. If you come and check third position, the third position is r, whereas r is not matching with the third position in the second word, so I can simply delete r from it. So my final word will be ROSC. Okay, now if you see ROSC and we have ROS. Okay, now first three characters from the word is matching to first three characters in the word 2. Now I can simply delete the last character from the word 1, and this will make both the words as same. Okay, if you see, the total number of operations we have done is 1 2 3. Okay, we have done one replacement, one removal, and two removals, right? So idea is to find the minimum operations. Let's say we have two strings s1 and s2. Okay, and I am processing ith character from s1 and jth character from s2. Okay, and let's say s1 is of length m and s2 is of length n. I am trying to process ith character from s1 and jth character from s2. Okay, so when I am looking at these two characters, okay, there are two possibilities: either these two characters will be equal or they will not be equal. Okay, if both the characters are equal, that means I can simply move to the next position and try to match the try to get the minimum operations required to match the rest of the string, right? So let's say I have a function called f of I comma j, which will tell me the minimum number of operations to convert s of I till end to j of I till end. Okay, let's just define this as our state. Okay, where I will convert my s of I till end to j of I till end in minimum number of operations. Okay, that is what this function will tell me. Okay, if both the characters are same, then I don't have to include any operations. I can simply go to the next string and get the answer from the next string. So that is what I am doing. Okay, the answer will be f of I plus 1 and j comma 1 if both the characters at I and j are equal. If the characters are not equal, then I have various options. The first option is to delete, right? If I choose to, sorry, first option is to insert. Okay, let's say I'm inserting at this particular position. Okay, that means in the end I have to make s1 to s2. So whatever character I have at j, I will, let's say I'm inserting over here, but still I have to convert this entire string to j plus 1, because j is matching, because the same character we have inserted over here. So our end goal is to convert from j plus 1 till l. Okay, from I till n you have to convert it to j plus 1 till n. Okay, so whenever we are inserting, there will be one operation included and my original string will remain same, but since I have matched the character at j, I will be trying to convert this entire string from I till n to j plus 1 till end. Okay, the second option is to delete. Okay, let's say I am deleting the character at I, that means still I have to convert this entire string into this entire string. So only my j will increment, whereas sorry, my I will increment, whereas my j will remain as it is. The third option we have is to replace. Okay, if I simply replace a character at I with character at j, that means one character has been already matched. Now I have to match this entire rest of the string uh, to this, right? So I will also increment and j will also increment. Okay, now whenever the characters are not matching, our final aim is to, since our final aim is to minimize the number of operations, so we will take minimum of all these three. Okay, whenever there is a mismatch in character at I and j. Okay, now that we have understood the recurrence relation, okay, whenever there is a match and whenever there is a no match. Okay, now there will be a point, if you notice in our recursion relations, we are either incrementing I or we are incrementing j. Okay, so there will be a point where our entire string in s1 we have matched with entire string in s2. That means I has reached the end and j is also reached the end. That means there are no more characters to match, right? So I will simply return 0. Okay, when both I has reached the end and j has reached the end. If simply I has reached the end but j is not reached the end yet, okay, that means I have to match the empty string with this string. That means I have to delete all the characters from s2. So that is what I am doing here. If I has reached the end, that means I have to delete all the characters from s2. So the number of characters from j till end is basically n minus I. Okay, now if let's say I is at this particular position whereas j has reached the end, that means s2 is empty string and this is some valid string and this is an empty string. Now I have to convert a string of certain length to empty string. That means I have to delete all the characters from s1. So the length from I till m will be m minus I. Okay, if you see, we can actually club these two into one single relation where I is equal to m or j is equal to n. We can simply take minimum of n minus j and m minus I. Okay, so these are the base cases and this is our recurrence relation. Okay, if you draw the tree diagram, you will notice that there will be certain states which will be overlapping. Okay, so your tree will basically grow and there will be certain states which will be overlapping. So whenever we have overlapping problems, we will be using dynamic programming. Okay, what does dynamic programming states? We will just cache the values which were already computed and then we'll reuse it whenever it is required, right? So let's just jump to the Leetcode and try to look at the implementation. Okay, so I'm back to my Leetcode. So as I mentioned, so we need a function. Okay, we need a function which will tell me the minimum number of operations required to convert s1 from I till end to s2 from j till end, right? So I have just defined certain variables at class level so that I don't have to pass those information to my recursive functions. So what I have done is, if you see, I'm just calling my recursive function which is bird1 and bird2. You can name it in real world interview. Try to have these names as meaningful as possible, because I just name it as recursive because I'm going to also explain you how the iterative approach will also look like. So that is why I have just named it as recursive. Have some meaningful names to your functions and variables in a real world interview. Okay, but keeping that aside, let's try to look at the core implementation. So I just defined s1 and s2 at the class level, and m and n, where m is the length of the s1 character and n is length of the s2 character. So as you can see, s1 is point to word1, s2 is point to word2, and m is the length of s1 and n is the length of s2. And so the first base case is basically if both the strings are empty, that means I have to return 0, or else I have to basically return the maximum of m minus I and n minus j. So this is where at least one of the strings is empty and another string is non-empty. Then I have to basically delete the characters from the non-empty string. Those will be the total number of operations, because we will be deleting all the characters from the non-empty string and convert it to an empty string. Okay, all the operations will be coming from delete. Okay, now if the characters are same, then my answer will come from I plus 1 and j plus 1. Okay, f of I plus 1 and j plus 1. And if my characters are not same, then my answer will be coming from f of I j plus 1 and I plus 1 j and I plus 1 j plus 1. This is basically we are inserting uh, character at ith position. Okay, here we are replacing, here we are deleting the character at ith position, and here we are replacing the character at ith position. Okay, so that these are the recursive functions which I mentioned. In the end we want to minimize it, so that is what I'm taking minimum, and each one of these each one of these will contribute a single operation, so that is why in the end I'm adding 1 to it. Okay, now that I have also mentioned, there is there are certain overlapping problems, so we don't have to recompute those answers again and again. If you see, I is going from 0 to n m and j is going from 0 to n, so the total number of unique states which our function can go through is basically m times n. So we will be having a 2D array of size m plus n. I just defined dp which is of integer array of size m plus 1. If an answer to a particular state is not computed, then if it is already computed, then I will be returning it, or else I will compute the answer and I will store it in my dp. Okay, yeah, so I hope you understood the problem explanation, the recursive implementation. If you like the explanation, hit the like button, hit the subscribe button, and also share your valuable feedback in the comment section. Let's also try to analyze the time complexity and space complexity over here. The time complexity over here will be big of m into n, because we are filling all these states of all these states. Okay, and the space complexity will be the extra space which we are using in order to solve this problem. We are creating a 2D dp array of size m into n, so the space complexity is also big of m into n. Okay, so if you keenly observe, there will be certain states. Okay, if you keenly observe at any given point. So before jumping dive into optimization, let me also show you the iterative way how this problem can be implemented. Okay, as I mentioned, uh, we are processing states of m into n, right? Total your number of unique states are m into n, so we will be requiring a dpr of size m into n. So I just had m plus 1 and m plus 1, so that I don't have to handle the boundary conditions. I had this plus 1 to handle the boundary conditions efficiently, because if you see, when I is equal to m, j is equal to n, then I have to return 0, right? So in order to have the state of m and n, so I should also have the same value in my 2D array as well. So that is the reason we have a size of m plus 1 and n plus 1, so that I can have a cell of mn. Okay, and if you keenly observe, okay, we are calling f of 0 to n, and the value of I is going from 0 till m, and j value is also going from 0 to n. Okay, in top down approach it is going from 0 to m and 0 to n, whereas in the bottom up approach we will come in the opposite direction. So we will be coming from m minus 1 till 0 and n minus 1 to 0. So before that, we also need to populate these states. Okay, these states are basically when we have the first character, the s1 has empty string and s2 is some non-empty string. That means in order to convert s1 and s2 both as equal, okay, this is an empty string and this is a non-empty string, that means I have to delete all the characters from s2. So that is what I am doing here. When s1 is empty, that means we are at the end of the s1. Okay, and the total number of operations required to convert s1 into s2 from I till j, so from j till end, will be n minus I. Okay, the similar way, if s1 is non-empty and s2 is empty, then we have to delete all the characters from s1. So whatever characters we are deleting, those many that will be the operation, so the operations will be m minus I. Okay, now that we have populated all the base case values, okay, if you see, these values were already populated and these values were also populated. Now we have to only worry about these two cases, right? So I will be going from m minus 1 till 0 and n minus 1 till 0. If both the characters are same, then my answer to I comma j will come from I plus 1 and j plus 1. Both the characters are not same, then my answer will be coming from all these three states. Okay, if you see, I've just converted my recursive relation into my iterative approach. Okay, and I've just populated in the same way our recursion is filling. Okay, so you just have to observe how your recursion will fill all your states, and you have to replicate the same thing in your iterative approach. Okay, the iterative approach will be better than the recursive approach because we won't be having the recursive call stack over here. That is the main benefit from which is coming from the iterative approach. Okay, if you see, the time complexity is same exactly, which is big of m into n, and space complexity is also big of m into n. Okay, the only optimization which is coming from the iterative approach is basically the where this approach will not take any extra stack space for your function calls. Okay, so my final answer will be lying in dp of 0 comma 0, right? So this is iterative approach. Okay, there is still a scope for optimizing your iterative approach. Okay, at any given point, answer to my state is only coming from I plus 1 and j plus 1, right? Answer to a current row is coming from the next row, right? If I'm processing the ith row, then my answer is coming from I plus 1th row, right? So at any given point, I only have to keep track of two rows, right? If I can do that, then we can actually reduce our overall space complexity to big O of n, right? So that is one optimization which can be done. Okay, I highly recommend all the viewers to convert this solution into a better space solution where the space complexity will be big O of n. Okay, since I've already explained the solution to you, I highly recommend all the viewers to try this and post it in the comment section. Anywho, I will be explaining this optimized space solution in the next video. Stay tuned for the video. Okay, and also if you like the explanation, hit the like button, hit the subscribe button, and share your valuable feedback in the comment section. Do check out other videos from the Leetcode dynamic programming study plan playlist, and I will be posting the solution in multiple languages such as Java, JavaScript, Python. Feel free to check it out. I will be providing link in the description section. Thank you.